Alright, now guys, here's what I want to look at. We're looking at beginning proofs. Sam? So, guys, when we talk about proofs, a lot of things that we do in this class, like high school loves two-column proofs. Absolutely loves them. I don't get it. I don't understand the obsession with them. It's a two-column proof. It's not even the best way to do a proof. In fact, when I got into college and took the college geometry class, we didn't do a single two-column proof at all. It was all done by paragraph proofs. So that's what you're supposed to do. Part of my standards. So remember, we talked about that. It does kind of help you guys develop a level of structure with your logical reasoning. That's basically one of the big advantages here. When we really look at this, when we look at how a proof is structured, especially in two-column proofs, a couple of things are worth noting. First, you have two columns. One is called the statement problem, or a column, and that's where you're going to show your steps. Alright, so the statement column is where you show your steps. The other column is called the reason column. It's where you justify your steps. So you're always going to have a statement column, you're always going to have a reason column. So a lot of times will happen, especially in our high school proofs, some blanks will be put in the proof. Now again, since we're just kind of starting here, I've given you all of our statements. We now just have to go in and justify every statement. Now, everybody in this room should be able to get one line of every single proof correct. Everyone. Because the first line of any proof is always one. Always given. What information are you starting with? And that is your first reason. How do we know that 2x minus 7 is equal to 1/3 x minus 2? Because it is given to us. So the first line of any proof is always the given, or the given statement. All right, now when you're doing proofs, I can give you guys some general guidelines, but every proof is different. Just be aware of that. Every single proof is different. So, like I said, some general guidelines. You do have to think when doing these. First thing I always try to get students to understand, what changes? Look at the previous line, go to the next line. What changed from the top line to my second line? Cheyenne?
You're multiplying 3 on both sides.
Yeah, so therefore, why is that okay? That's the multiplication property. That's what we're going to put down. The multiplication property. Oh, but we haven't distributed yet. We've only multiplied. Okay. Line 3, what have I done? Now on line 3, I've now distributed the 3 into those parentheses. So line 3 is actually the distributive property. And so a lot of times what you guys will see is that setup where you're multiplying first and then you distribute. Okay, line 4. What changed? What did we do? Balin?
Add 21 to
Say that again?
add 21 to both sides.
No, you're down one too many. We're on the 5x minus 21 equals negative 6. What did we do there? What got us to that point? So guys, again, in order to find out this step, what did we do to go from here to there? Cordell? We subtracted. That's the subtraction property. And now Bailey. Now what do we do? That's the addition property. We added 21 to both sides. And then finally, the last step there, what do we do? Define it.
Oh, okay, I get this now. Because I kept putting it like, I would say that I put division on 5x equals 15 because I thought like that this is divide there.
No.
That this
You're justifying every step. So it's basically, you're almost like a step behind every time.
Okay.
Okay? The question we ask ourselves is, what did I do to get to here? That's the question you're asking.
Okay.
Okay? Got it?
So when we face one of these problems, would we write it like that? With the
Yes.
given? Well, probably, because that's what we do.
That's exactly what you're going to do. Okay?
Thank you.
Always. Yeah. And even when we do paragraph proofs, you're always going to say, since we were given this information, and then your proof kicks off from there. So now, a couple of things to know about proofs. Did I say when I was adding, subtracting, or multiplying? No, just that's the multiplication property. That's the distributive property. You're justifying the steps of the problem. That's it. I can do this because of the addition property. I can do this because of the distributive property. That's what you're doing. You're justifying every one of your steps. Let's try another one. Christina, first line of any proof. Given. Very good. I guess we're hurrying to copy this all down. So it's one step at a time though. Kayla. What changed, right? What changed? That's the question you ask yourselves. We're multiplying by 3, therefore which property? Multiplication. And a lot of times, guys, I will just accept, a little bit of abbreviation from there. That is good enough for me. The fact that you know to multiply, we're good. All right, Alexis, what about the next one? Yeah, it's the distributive property. Okay, Justin, what about the next one?
Subtraction.
That's subtraction property. Guys, by the way, with subtraction, make sure you do SUBT. Somehow, sometimes that might get confused with substitution. You want to make sure if you're going to abbreviate it, make sure to abbreviate for subtraction, not just SUB. All right, and then finally, the last statement of the day, Danielle.
It'd be addition? No, division.
Division, there we go. All right, you guys got this? Okay, so we're going to practice some more.